What's up, guys? Welcome to our PLG helping video series, and today is going to be our first series, which is about the topic of portfolio diversification. So, in this video, we are going to cover basically two things. Firstly, we will get to know some basic definitions of portfolio diversification, including how that works in your investment decisions. And secondly, we will use a past exam question to help you guys really understand how can you apply those knowledge in dealing with those kind of problems. Okay, so if you're ready, let's get started. So first, let's focus on this portfolio. So what is a portfolio? Actually, a portfolio can be regarded as a group of different investments, okay? A group of different investments. Therefore, by constructing an investment portfolio, what you can achieve is that, based on other research, is that you can really eliminate parts of your investment risks. So there is a diagram like this. This is the number of assets in your portfolio, and this is the total risk of your portfolio. And we observe that as the number of assets increase, and we can see the risk is decreasing. And it will approach a certain level. And you will learn more about this in finance, but we will not cover this in details. But anyway, all we want to show you here in this unit is that by constructing a portfolio, we will achieve what we call portfolio diversification. And this is the result of having a portfolio whose risk is less than the risk that construct the portfolio, less than the risks of the investments that construct the portfolio. So for example, if I have two assets, asset A and asset B, and A's expected return we denoted as R1 and B's as R2. And we also got sigma 1 as the standard deviation of A and sigma 2 as the standard deviation of B. So if we define a portfolio to be some proportion in A and some proportion in B, for example, the weight in A, we call it W1 and W2. So what we mean by the risk diversification is that our portfolio risk, or sigma P, will be less than sigma A as well as less than sigma 2. So this is what we mean by portfolio diversification, okay? So all the tasks that you are required to do is actually to calculate the portfolio return as well as the portfolio variance or standard deviation. So if we denote RP as the portfolio return, sigma P as the portfolio standard deviation, and we denote the covariance between A and B is sigma 1, 2, or the correlation coefficient of AB to be rho 1, 2. Then we will get the formula as RP will equal to the weighted average of R1 and R2, so which is W1 R1 plus W2 R2. And sigma P square will be given by W1 square, sigma 1 square plus W2 square, sigma 2 square plus 2 times W1, W2 times sigma 1, 2, which is the covariance between those two portfolios. And in addition, this one can be rewritten as the terms in the rho, which is given by 2 times W1, W2, sigma 1, sigma 2, and rho 1, 2. So those are the formulas that you probably need to put in your formula sheet in the exams. So how can we apply all those knowledge in the real-life examples? Now, let's look at a sample question. This question is from, I believe, from probably 2016. This is semester 2016 as the file, the exam paper I've uploaded on the PLG folder. So let's look at this question together. It says Sarah plans to invest some of her savings into investment products, namely product A and product B. Suppose that the mean and standard deviation of the annual percentage return of product A are 20% and 25%. So this is the mean of A and standard deviation of A. Therefore, we just put this 20% as R1 or RA or whatever you like, and this 25% as sigma A or sigma 1 or whatever. And the mean and standard deviation for the annual percentage return of product B are 12% and 15%, so R2 and sigma 2, respectively. To diversify the investment risk, Sarah decides to build an investment portfolio and invest 6% of money into product A and remaining 40% into product B. Therefore, 60% should be weighted on A, which is W1, and the remaining 40% into product B, this should be W2. Okay, I'll give you 10 seconds to read this question again, and then we shall start doing this question. Or you can just press the pause button if you want to try this question by yourself, okay? All right, 5, 4, 3, 2, 1. All right, now let's look at the first question. It is asking us to find the expected annual percentage return and standard deviation of the portfolio if the correlation coefficient between product A and B is 0.5. So, if it is correlation coefficient, we know that this is giving us row 1, 2 instead of the covariance, right? All right, so then things becomes very easy now. What we need to do is actually to apply the portfolio formula. So for example, if I define RP as the portfolio return, then RP must be equal to what? All right, great. So it should be 60%. 60% on R1, which is 20%, plus 40% on RB, which is where is it? Okay, 12%. And now you can take out your calculator to calculate this result. I still haven't done this, so let's do it together. So this should be 0.6 times 0.2 plus 0.4 times 0.12. And finally, we got the result of 0.168, which is 16.8%. Therefore, the portfolio return is 16.8%. All right, now, in terms of portfolio standard deviation, what we actually have was the portfolio portfolio variance formula. So after using this formula, we can actually take a square root on it and then get the portfolio standard deviation. Therefore, let's do it together. So by plugging in all the numbers in the formula, we got W1 squared, which is where is it? Okay, 0.6 squared times standard deviation squared, 0.25 squared, and then plus 0.4 squared. This is W2 squared times where is it? 0.15 squared. And then we've got 2 times the weight 1, weight 2 times the row 1, 2, sigma 1, sigma 2. Therefore, the formula should be 2 times, where is it? Weight 1, 0.6, weight 2, 0.4, sigma 1, 0.25, sigma 2, which is, where is it? 0.15, and then times row 1, 2, which is 0.5. So after calculating this, we know this is the portfolio variance instead of the portfolio standard deviation. So let's do it together quickly. It's going to be 0.6 squared times 0.25 squared plus 0.4 squared times 0.15 squared plus, okay, let's plus 2 times, all right, 2 times 0.6 times 0.4 times 0.25 times 0.15 times 5. Okay, and then finally, by pressing this equal sign, we've got, okay, the portfolio variance is 0.0351. So this is 0.0351. However, the portfolio standard deviation will be the square root of this 0.0351, and we've got, square root of the answer is 0.1873. 0.1873. Cool. So this is how we calculate the portfolio return and portfolio standard deviation. Well, now let's look at the second requirement question for this question. Okay, so it is asking us to find the expected annual percentage return and the standard deviation of the portfolio if the correlation coefficient between A and B is minus 0.5. So everything remains unchanged. The only thing that is different is the correlation coefficient. So do you think the changing correlation coefficient will affect the portfolio return or the portfolio risk? Right, it will only affect the portfolio risk instead of the portfolio return. Therefore, the portfolio return is still 16.8 as what we calculated here. But the portfolio variance or standard deviation becomes, actually only here becomes a minus sign, right? So let's just try to write down this formula together, okay? It should be what? Yes, 0.6 squared times what square? Exactly, 0.25 square and plus, 0.4 square, well, let's see, times 0.15 square plus, well, not plus here, but minus, because this 0.5 becomes the minus 0.5, therefore we put a minus sign here, and it's going to be 2 times 0.6 times 0.4 times 0.25 times 0.15 times 0.5. Okay, actually, you don't need to type in this formula again because we can go back to, this equation and let's just change that plus sign into the minus sign here, right? Okay, so just this guy. Delete it and put a minus sign here. And then we will get a result of 0.0171. So this is 0.0171. But never forget, this is the variance. But what we need is the standard deviation. So sigma p becomes the square root of 0.0171, which is the square root of the answer. And this will be given by a 0.130708, okay, which is 0.1308. Okay, let's compare those two results. 1.1873, this is 18.73%, and this is 13.08%. So which of those two scenarios have you found to have achieved our what we call the portfolio diversification? Which one? Well, let's see. the standard deviation of A is 25% and B is 15%. Okay, so I will write a 25 here and a what is that? Okay, 15 here. So do you think this number is less than both of those two numbers? No. So in this case, we can see if the correlation is positive, it's really hard, it's impossible to achieve this kind of portfolio diversification. But in this case, we can see, we compare it with 25% and 15%, we can see that this number is less than 25% as well as less than 15%. And we can see that in this scenario, the portfolio diversification has been achieved. Cool. So that is about question 3 here, actually. So does Sarah achieve portfolio diversification if the correlation is 0.5 and minus 0.5? We can say that Sarah achieved portfolio diversification when the correlation is minus 0.5 because the portfolio standard deviation 13.08 is both less than 25%, which is the risk of stock A, as well as less than 15%, which is the risk of the investment B. So in this way, we say the portfolio diversification has been achieved. Alright, so that's all about today's question. We can see that in this video, we've learned what do we mean by portfolio diversification. We know that by constructing a portfolio, especially when we increase the number of assets in our portfolio, the risk can be significantly eliminated, but to a lower limit somewhere. And we know this is called systematic risk, right, in finance. And then we define a scenario when we're considering a two assets portfolio A and B. And we know the formula of the portfolio return and portfolio risk or variance. And we use this sample question to illustrate how can we achieve the portfolio diversification. So that's all for today's video. Thank you very much for watching. If you like this, please click the like button. If you don't like it, but just don't click the dislike button. And if you want more video from us, please smash the subscribe button. Thank you very much for watching. Wish you the best luck in your exams. See you guys later.